Have you ever looked inside a PC and wondered what do all these parts actually do? A CPU, a GPU, RAM, SSD? It can look confusing at first time. But here's the good news. By the end of this video, you will understand exactly what every major PC component does, why it is important, and which parts have the biggest impact on gaming performance. Let's get started. First, we have CPU. The CPU, or Central Processing Unit, is often called the brain of the computer. It handles calculations, game logic, AI, physics, and almost everything happening in the background. Think of the CPU as the manager of your entire system. A faster CPU means smoother gameplay, especially in competitive games where high frame rates matters. Popular gaming CPUs today include AMD Ryzen and Intel Core processors. Without a CPU, your computer simply cannot function. The CPU functions fetching, decoding, execute, storing, repeating. From RAM to CPU. Fetching, the CPU fetches instruction from memory and decoding the instructions to understand what to do. The CPU after that executes the instructions using ALU. Then in the fourth step, the result is stored in a register or back to memory. The fifth step, then the last one, the CPU repeats the cycle for the next instructions. And then we have the RAM. It means random access memory. Now let's talk about the RAM. Unlike storage, RAM only keeps temporary information while your PC is running. Games use RAM to quickly access textures, maps, characters, and other data. If you don't have enough RAM, your system becomes slow and may start stuttering. In these days, 16 GB is considered the minimum for gaming, while 32 GB is becoming the new sweet spot for demanding games and multitasking. How RAM actually works? We have 5 steps. First step, request. The CPU sends a request to read or write the data. The second step, RAM locates the memory addresses specified. The third step, read or write. RAM reads the data from the addresses or writes the data to it. The fourth step, store or send. If read, RAM sends the data back to the CPU. If write, RAM stores the data. The fifth step, RAM is ready for the next request, repeating the cycle. Let's talk now about the motherboard. The motherboard is very important because it is gathering all these components together in one system. This is the main circuit board that connects your components together. Your CPU, RAM, storage, graphics card, everything plugs into the motherboard. It determines which CPUs, memory, and storage devices your PC can support. How motherboard works? The first step, we have the power. Power from your PSU or power supply unit is delivered to the motherboard. Second step, distribute. The motherboard distributes power to all components. The third step, connect. It connects all components and allows them to communicate with each other. The fourth step, communicate. Data is sent between the components through the chipset and bus lanes. Then control. The BIOS or UEFI and chipset manage and control all operations. The last step, output. The results are sent to the output devices, monitor, storage, network, keyboard, etc. You need to choose your motherboard very carefully. The right motherboard is all about compatibility and future upgrades. Let's move on to the GPU, graphics card. Now we reach the most important component for gamers, the graphics card, also known as the GPU. This is part responsible for rendering everything you see in your screen: lighting, shadows, textures, reflections, ray tracing. All of these things processed by the GPU. If you are building a gaming PC, this is usually the component where you will spend the biggest portion of your budget. A stronger graphics card means higher FPS, better graphics, and smoother gameplay at higher resolution like 1440p or even 4K. How the graphics card actually work? First of all, the graphics card GPU receiving the data. These type of data which is like a commands from the CPU through the PSI interface. Second step, process. Thousands of GPU cores perform parallel calculations for graphics, lighting, AI, and computer workloads. Third step, which is render. The GPU transforms 3D models, textures, shadows, and effects into complete image frames. The fourth step, storing. High-speed GDDR7 VRAM temporarily stores textures, geometry, shadows, and render data. The fifth step, which is cooling. The cooling system keeps the GPU at optimal temperatures. And the last step, the output. The finished image is sent through HDMI or DisplayPort to your monitor. Let's move on to the SSD. Next comes storage, specifically the SSD. Unlike old hard drives, SSDs are incredibly fast. They include loading screens dramatically Games launch faster, Windows boots faster, everything feels more responsive. An SSD won't increase your FPS, but it makes your entire PC feel much faster. That's why almost every modern gaming PC uses SSD storage. How SSD works? First, receiving data. The SSD receives data requests from CPU through the PCI interface. Then it will process. The controller processes read or write requests and manages data flow, security, and error correction. Then the third step, data is stored in NAND flash memory cells permanently. The fourth step, retrieving. When needed, the data is retrieved back from NAND flash quickly. The fifth step, transfer. High-speed PCI 4.0, X4 interface or 5.0 transfers data to the CPU and system memory. The last step, loading. Your system and applications load faster with high speed and low latency. Then let's move on to the PSU. Now let's talk about the power supply unit or PSU. This is a component that provides electricity for your entire computer system. Think of it as your PC's heart. A cheap power supply can damage expensive components. That's why it is important to choose a reliable PSU with enough wattage for your system. Never underestimate the importance of a quality power supply. Now let's talk about the PC case. It's more than just looks. It protects all your hardware while helping airflow move through the system. A good case keeps temperatures lower, reduces dust buildup, and makes cable management easier. Some cases also offer better support for larger graphics card and liquid cooling systems. Good airflow can significantly improve your PC's cooling performance. Let's talk about the CPU cooler and liquid cooler. Every CPU generates heat. That's why you need a cooler. There are two common types: air coolers and liquid coolers, also known as all-in-one. Air coolers are simply reliable and often quieter than people expect. Liquid coolers provide excellent cooling performance and are popular in higher-end gaming builds. Both options work well. The best choice depends on your CPU, your budget, and the look you are going for. Case fans. Finally, we have the last component, which is the case fans. Their job is simple: move cool air into the case and push hot air out. Good airflow helps every component stay cooler. Lower temperatures can improve performance, reduce noise, and even increase the lifespan of your hardware. Many beginners of PC builders focus only on powerful components, but airflow is just as important. And that's every major PC component explained. Now you know what each part does and why it matters. Building a PC might seem complicated at first, but once you understand these basics, everything starts making sense. You need to focus on the compatibility with the motherboard, CPU, RAM. It is very important to avoid any issues during booting the Windows or anything else. If you found this video helpful, don't forget to leave a like and subscribe for more PC hardware guides, gaming tips, and beginner-friendly tutorials. Thanks for watching. As always, this is Amori Show, and I will see you guys in the next video.